Hello everyone. This is Gayatri Priya, Assistant Professor in the Department of EC of RMD Engineering College. In today's sessions, I will let you know how to design and simulate a low pass filter using operational amplifier. Right? First, getting into OrCAD Capture, File, New Project, and giving a name. So let it be analog or mixed AD. Click OK. Create a blank project. OK. You will be getting a page like this. So in this place part, I'm putting op-amp itself. Click over the op-amp, left click, right click and end mode. Right? Okay. So let me flip this vertically. Okay. Now we need resistors. So R analog. So 1, 2, 3, 4. And apart from that, we need capacitors. Two capacitors. 1, 2, and more. Let me rotate this capacitor. Rotate it. And apart from this, we need a sinusoidal source. Sinusoidal source. Let me connect up here. Right click and move. So in this op-amp, the supply everything is present inbuilt. So no need to connect any power supply apart from this at pin number 4 and 7. Okay. Place the wire. You can adjust depending upon our position. And this has to be connected here. The resistors are in the series arm and the capacitors are in the shunt arm. Similarly, at the inverting terminal, I am connecting these two resistances. So this end has to be connected to pin number 6, that is the output. And similarly, this capacitor has to be connected to the pin number 6. Okay. I am extending this line in order to give ground connection. Right? Getting the ground, ensure it is 0 capsule. The name is mentioned as 0. Click OK. One at this capacitor, the another at this supply, and one more for this resistance. Right? The connection is done. Now, coming up for the design part. So we know that, but before that, we need to give the supply. V off is 0 volt. Let the amplitude be some 2 volt. And this frequency be 1000 hertz. And this be 2 volt. Okay. Now coming to PSpice, new simulation profile. So learn by doing, to create. So click over this. Click on the AC sweep. Let it be in logarithmic. The start frequency may not be 0 and therefore let it be 10. And the end frequency may be some 10,000 or more than that. And the division is 10 or 100. Okay, apply. Okay. Now run PSpice. You will be getting a blank thing. The x-axis will be having the frequency. So come to trace, add trace. We want the gain in dB. Therefore dB of, within the bracket mention output of our IC divided by look at the resistance value. Okay, this is R3 resistance. Okay, the input is going to be R3. So inside this bracket this should come, divided by VR3, click OK, right? So this is the response of a low pass filter. So from this we could identify the cutoff frequency is approximately nearly some 100 kilohertz. Okay, this cutoff frequency is nearly some 100 kilohertz. And if you are going to measure the gain in dB, in the sense you can come 3 dB down and you can measure what is the gain present here. Okay, so nearly it is some 10, 20, 30, 40. So it may be some 8 dB or something like that. Below 3 dB, in the sense it will be around some 5 dB. Therefore you will be cutting this frequency at 100 kilohertz. Okay, so tentatively the frequency is going to be, cutoff frequency is going to be 100 kilohertz over here, right? So if you want to view the output file, click view output file, right? And this is the netlist file you need to mention. What are the connections you are being mentioned? R is a resistance R1 connected between these two nodes, R2, R3, R4, C1, C2, like that you can mention like this, right? Similarly, we can proceed with the high pass filter just by interchanging this resistor and the capacitor. Okay, so this is called a second order low pass Butterworth filter. Why? In the sense, actually here we could see the design part. Okay, so this is a second order low pass filter. Okay, so what we have done here is exactly mentioned. So instead of connecting these dB everything and all, if you are not clear about that, you can come to place PSpice itself. You will be having marker. Okay, in the marker you can go to advanced level dB magnitude of voltage. You can click over this also. Coming to marker, in the PSpice, marker, advanced marker, dB magnitude of voltage, and I can place over here. Now we can run. Can you see? Right? So without using the calculations and all, directly you can measure the dB voltage. Right? That is the gain in decibel, voltage gain in decibel. Right? So hope you understand these sessions. Thank you.